All right, here we go. This is the area one. All right, guys. All right, so this one here wants the area between x cubed plus 4 and 0 and 1. So x cubed plus 4 looks something like, so it's already above the x-axis between 0 and 1. So I'm just going to integrate between 0 and 1, x cubed plus 4 dx, and this will give you the area under the curve between 0 and 1. So x to the fourth over 4 plus 4x between 0 and 1. So it is 1/4 plus 4. And then the 0 is 0. So let's see, 1/4 plus 16 over 4. So that gives you 17 over 4. Crisanto does not approve. I'm kidding, miss. All right, calculate the area. So I see this here. I'm noticing that as long as x is positive, this will always be above the x-axis. So the first thing I would do is I would distribute that. So that would be x cubed plus 4x squared. And since I know I'm above the x-axis between 0 and 5, I'm just going to integrate 0 to 5 of x cubed plus 4x squared. So we have x to the fourth over 4 plus 4x cubed over 3. And this is evaluated from 0 to 5. So let's see, this might be too big of a number for me to do. 5 to the fourth divided by 4 plus 4 times 5 cubed over 3. I'm okay with you using the calculator to add those guys up. Let me do it really quick. 5 to the fourth divided by 4 plus 4 times 5 to the third divided by 3. Math fraction enter. And I get 3875 over 12. So there it is. Do not use an integral equation to get that. I don't mind if you use a calculator for that, maybe. It probably could have been done by hand. It could have been done by hand. Oh, well, the microphone's over here. But okay, I'll talk louder so you can hear. Sorry, miss. I want my fans to be happy, so I'm going to talk louder. Calculate the area between, okay, I'll talk to you guys here. So I want the area of x squared minus 36 and the x-axis between -2 and 6. So we recognize that this graph,
Hey, Travis, please pardon the interruption. Could you send Hannah Matthews down to the front office?
yes ma'am. So between -2 and 6, I notice that the area is below the x-axis. If I want to have it positive, I'm going to have to do 0 minus x squared minus 36. If you want it to be a positive, you can always just integrate x squared minus 36 from -2 to 6 and then just turn it to a positive. But if you want to be, 100% correct, I'm going to integrate negative x squared plus 36, and now we're going to force it to be a positive from -2 to 6. So here we go. So that's going to be negative x cubed over 3 plus 36x. And I'm evaluating that from -2 to 6, upper minus lower. So -6 cubed over 3 plus 36 times 6, whatever that is, minus negative on the outside, -2 to the third, so it's going to turn to a positive there, over 3 plus 36 times -2. And I'm just going to use my little calculator here for that. 6 to the third divided by 3 plus 36 times 6. Okay, so I get 144 from this one right here. And then, let's see what I get on the other one. -2 to the third divided by 3. 36 times -2. And I get a -208 over 3. So 144 minus. And when I do that, oops, I get 640 over 3. Hopefully that all made sense, guys. All right, calculate the area between the graph of cosine and the x-axis. So cosine x starts at 0, 1, and at pi over 2, I know that it's 0, and then 5 pi over 6, I know that that's going to be, let's see, it's going to look like, so here's pi over 2, and this guy here is 3 pi over 2. This one's pi. So 5 pi over 6 is really close to pi, so they want this area here. Now notice that's negative, so if I want to turn it into a positive, I'm going to have to go, I'm going to have to integrate a negative cosine x. And if you're wondering why I wrote negative cosine x, because this is like y equals 0 here, so 0 minus cosine x will give me this area but positive. So here we go. I'm going to write pi over 2. I'm going to write 5 pi over 6. So antiderivative of cosine x, let's see, negative, and pi over 2 to 5 pi over 6. So you're going to need a little bit of pre-calc, guys. All right, here we go. Upper minus lower. I'm going to factor out the negative. So here we go. Sine of 5 pi over 6 minus sine of pi over 2. Negative, and the sine of 5 pi over 6 is a half, minus sine of pi over 2 is a 1. So negative, negative half, so negative times the negative is a positive. Cool. On this one here, it says find the area bounded by the curves y equals 2 squared of x plus 7 and y equals 1/4 x squared plus 7. So I notice, here's what I notice. I notice that the y-intercepts are the same. So when I graph this, they both start off like this. The square root function is going to look like that, and the parabola is going to look like this. And they intersect at a certain location, and they want that area. Okay, so how do I do that? I set them equal to each other. 2 squared of x plus 7 equals 1/4 x squared plus 7. The 7's cancel out. And I think I want to divide by 2, guys. So divide by 2, divide by 2. So I have the square root of x equals 1/8 x squared. I'm going to move the square root of x to the right. 0 equals 1/8 x squared minus square root of x. And I'm going to factor out a square root of x. So if I factor out a square root of x, I have 1/8 x to the 3/2 minus 1. So one answer, remember all this equals 0. So one answer is 0, which is obvious. And the other answer, let's see, 1/8 x to the 3/2 equals 1 times 8 times 8. X to the 3/2 equals 8. Raise this to the 2/3. Raise it to the 2/3 because you just want x. So the third root of 8 is 2, and 2 squared is 4. So there it is. And then I just test it. And maybe you could have figured it out just by looking at it. The square root of 4 is 2. 2 times 2 is 4. 4 plus 7. 7, 8, 9, 10, 11. And then let's see, 4 squared is 16. 16 divided by 4 is 4. 4 plus 7 is 11 again. So there it is. So I'm going to integrate from 0 to 4. And then the function that's on top is actually the square root function. So 2 square root of x plus 7 minus 1/4 x squared minus 7. 7's cancel out. And I'm just going to take an antiderivative. So here we go. Do I have enough space? I'll write it up here. Integral 0 to 4, 2x to the half minus x squared over 4 dx. So let's see, 2x to the 3/2 times 2/3 minus x cubed over 4 times 3 is 12. And all this from 0 to 4. We don't have to worry about the 0. So let's see what we finally have. 4/3, 4 to the 3/2 minus 4 cubed over 12. And we get 4/3 times 4 to the 3/2 minus 4 to the 3rd divided by 12. Mass fraction enter. 16 over 3. And we probably could have done it by hand as well, but I just used my little calculator. Alright. Find the area bounded by the curves 3 minus x squared and 6 minus 4x. So this curve is going to look something like this. And then that linear line, remember, look, negative slope, is going to look something like that. So we care about this region. And actually the linear line is, the parabola is what's on top and the linear line's on bottom. So let's find out where these equal. 3 minus x squared equals 6 minus 4x. This is not to scale, by the way. It may not look like that, but this region is going to look like that. I'm going to move these to the right. 0 equals x squared. Let's see, minus 4x. Minus 3, so plus 3. So factor out, let's see, x minus 3, x minus 1. So x equals 3, x equals 1. So I'm going to integrate from 1 to 3. And then the line that's on top is the parabola, 3 minus x squared. And the line that's on bottom, 6 minus 4x. And I'm going to assume you know how to integrate. So, boom. Does that make sense, guys? Or no?
What did you do after the integral?
Well, I just integrated, but I didn't show it. Okay, I'll show it. They want me to show it. All right. So let's see. 3 minus 6 is a negative 3. So integral 1 to 3, negative 3. And then I only have a negative x squared, so minus x squared. And positive 4x. So let me rewrite it. Integral 1 to 3, negative x squared plus 4x minus 3. So here we go. Antiderivative, negative x cubed over 3 plus 4x squared divided by 2. So that's going to be 2x squared minus 3x. This is from 1 to 3. So I'm going to show the 3, 1 over here. So let's see. Parenthesis, negative 3 cubed over 3 plus 2 times 3 squared minus 3 times 3 minus, and then negative 1/3 plus 2 minus 3. So let's see. I'm going to have negative 9 plus 3 squared 9. 9 times 2 is 18 minus another 9. So that looks like it zeroes out. Negative on the outside. Let's see. 2 minus 3 is a negative 1 minus 1/3. So that looks like it's going to be a negative 4/3. And then I have a negative here, so that turns into a positive 4/3. So 4/3. Look, we did it by hand. All right, we did it. I want happy fans. I want my fans to be happy. All right, next one. Find the area bounded by the curves 3 squared of x and y equals x. So you have a square root curve, guys, and you have a linear line. So it's going to look something like this. 3 squared of x, and then a linear line. The 3 squared of x is going to be on top, and the linear line is going to be on bottom. And, okay, so let's start. 3 squared of x equals x. I'm going to move the x to the left. 3 squared of x minus x equals 0. I'm going to factor out a square root of x. I have 3 minus square root of x. So one answer is 0, and then the other answer is 9. So now that I know, I'm going to integrate from 0 to 9. And then again, we said that the square root function is the one on top, minus x dx. And here we go. Remember that 3 squared of x is the same thing as 3x to the half. Antiderivative of that is 3, leave a little bit of space. X to the 3 half divided by 3 half, which is the same thing as multiplying by 2/3, minus x squared over 2. And I'm evaluating this from 0 to 9. The 3's cancel out. So let's go ahead and work this. I think we can do this without a calculator, guys. The square root of 9 is 3. And then 3 times 3 is 9. 9 times 3 is 27. And then 27 times 2 is 54. And then 3 squared is 9. So 54 minus 9 over 2. Let's turn that into, did I do that right? Oh, no, that's an 81. 9 squared is 81 over 2. So I'm going to turn that 54 into 108. 108 over 2 minus 81 over 2. Let's see, 81, 91, 101, 107. Okay, so that's 27 over 2. And there you go. Another one bites the dust. Oh, no one caught it. I caught it though. You okay, Conchas? Okay. Make a note that Conchas was coughing. I'm kidding, guys. Find the area bounded by the curves 2x squared, negative 2 squared of x, and x equals 4. Oh, so there's an interesting graph. There's a parabola that looks like this, and then negative 2 squared of x is going to look like that, and x equals 4 is a vertical line like that. So it wants this region. So that's kind of nifty. They both touch at 0, and it's going to end at 4. And the graph on top is 2x squared, and I'm subtracting the negative 2 squared of x. So there it is. So I'm going to integrate 0 to 4 of 2x squared plus 2x to the half dx. I think we can do this by hand. So let's see, 2x cubed over 3 plus 2, leave a little bit of room, x to the 3 halves times 2 thirds. And that's from 0 to 4. So let's do the 4 first. 2 times 4 to the third over 3 plus, let's see, 2 times 2 is 4. 4 over 3, 4 to the 3 halves. Let's see, 4 times 4, 16. 16 times 4, 64. 64 times 2, what's that, 128? And then divided by 3. So I'll just leave that as 128 over 3. And then the square root of 4 is 2. 2 to the third is 8. 8 times 4 is 32. So 32 over 3. And then when I add 128 and 32, you get 160. Bless you. 160 over 3. You okay? Okay. 160 over 3. And there it is. You got that one down? Okay. The graph f of x shown below between negative 3 and 2. The area bounded between the curve, are you asking me? Of the x-axis negative 3 and 2. So this area here is 11 over 6. Area bounded between, all this area here is 9 over 2. Now remember, you're below the x-axis, so it's negative 9 over 2 if it's called signed area. And the area bounded by the f of x and the x-axis between 1 and 2 is 11 over 6. So this is symmetrical. Determine the area between negative 3 and 1. Oh, that's pretty straightforward. It's 11 over 6 minus 9 over 2. So common denominator, multiply this guy by 3 over 3. So 11 over 6 minus 27 over 6. So 27, 17, 16. Why did that take longer than necessary? Negative 16 over 6, let's reduce that. So that's going to be negative 8 over 3. There it is, guys. All right. Find the area of the region bounded by the graph and the x-axis. Find the area of the region bounded by the graph of f of x and the x-axis. Okay. X squared plus 4. Let's graph this graph. So x squared plus 4 looks like this. 2 squared is 4. 4 plus 4 is 8. So it's going to go like that. So I'm going to say this is 2. And this value here is 8. And then let's see, at 2, it's going to touch. And it's going to go all the way until it hits 10. Because 10 minus 10. So there's the area that I want. So here's what I'm going to do. I see a triangle. And so I'm just going to calculate the parabola between 0 and 2 of x squared minus 4. And then I'm just going to do a triangle, guys. So x cubed over 3 minus 4x between 0 and 2. So let's see, 2 cubed is 8, so 8 over 3 minus 8. So 8 over 3 minus 8 times 3, 8, 16, 24, so 24 over 3. That's supposed to be a plus 24 and 8, 24, 32. 32 over 3. Okay, and now this is a triangle. 10 minus 2 is 8. 8 times 8 is 64, and 64 divided by 2 is 32. So that's 32. 32 over 3 plus 32, so multiply that by 3. So 32 over 3 plus 30, 60, 90, 96 over 3. So that's 128. There it is. Find the area of the region bounded by the x-axis on the curve. So let's see which one's on top and which one's on bottom. So sine, here's cosine, and here's sine. So here's 0, and they're going to intersect at pi over 4, and then we're going to pi over 3. So between 0 and the region bounded by the x-axis and the curves. X-axis and the curve. So we're doing this. Okay, so I'm going to integrate 0 to pi over 4 for sine x dx, and then between pi over 4 and pi over 3 for cosine x dx. So antiderivative of sine is cosine, 0 to pi over 4, plus antiderivative of cosine is sine. Oh, this is negative. So sine pi over 4 to pi over 3. So here we go. Cosine of pi over 4 is square root of 2 over 2. I'm going to factor out the negative. Square root of 2 over 2, and then minus cosine of 0 is 1. Plus sine of pi over 3 is square root of 3 over 2. Minus square root of 2 over 2. Alright, so if I distribute the negative, we're going to have... Oh, remember, there's a 4 in the front and a 4 in the front. So there should have been a 4 here and a 4 there. Sorry about that, guys. So negative 2 square root of 2 minus plus 4 when I'm distributing that negative there. And then plus 2 square root of 3 minus 2 square root of 2. So these add up to a negative 4 square root of 2 plus 4 plus 2 square root of 3. And we look for that. And there it is. Alright, I hope you liked it, guys. So thumbs up if you liked it, subscribe if you loved it. Cortez is telling me no bueno, that she hated it, which I hope is not true, but alright.